In this video, we're going to look at how to calculate pH and go back from pH to a concentration. There are going to be 5 different equations that we're going to need, but a lot of them look very similar. Let's start with just the pH equations. If I'm trying to calculate pH, I'm going to start with an initial concentration. And if I take the negative log of that concentration, it's going to be the negative log of the hydronium concentration, this H3O+. If I take the negative log of that, that'll give me the pH. And then we also need to consider how to go from a pH to a hydronium concentration. Well, a log is just a way to get around something like this. If I've got 10 to the x, I can use a log to figure out what x is. It's just the inverse operation for this situation. And so if I want to calculate the concentration for the pH, well then I'm just going to take 10 to the negative pH. That'll be pretty simple to do. And then we also want to look at pOH. And pOH is going to be found the exact same way. So even though these are a few different equations, they're all very similar. And then the last equation is going to relate pOH and pH. And this is actually very straightforward. Since they are both a 14-point scale and they're just inverses of one another, then the pH for any substance plus the pOH of that substance will be 14. And all the acids and bases that we're going to be using in this video are going to be what's known as a strong acid or base. And a strong acid and base will completely dissociate into a hydronium and whatever's left over. So this will be something like hydrochloric acid. If I've got HCl, it will completely break up into that hydronium and the Cl minus. There won't be any of this left. That will all be gone. It will all have broken up, and it's not going to go back. So we can just use whatever concentration of that acid I've put into the solution. So let's start with an example. Let's use that hydrochloric acid right off the bat. Let's say I've got a Say I've got a 0.00054 molar solution of hydrochloric acid. What's going to be the pH of that solution? Well, I'm just going to take the negative log of that 0.00054. What'll that get me? That'll get me a pH of 3.27. Let's try another one. Let's do HNO3. Let's do HNO3 at a concentration of 2.3 E negative 5. What's that pH going to be? When I put that into my calculator, the pH is 4.64. All right, now let's try going back the other way. Let's say I've got a solution of sulfuric acid, H2SO4, at a pH of, let's say, 1.97. What's going to be the concentration of sulfuric acid in that solution? Well, I'm just going to take 10 to that negative pH, right? So in this case, it's going to be 10 to the negative 1.97. That will give me my concentration. 0.0107 molar. Now that's pretty straightforward. Now notice, as the pH is going down, our acid is more concentrated. So a lower pH means a more acidic solution. So let's do that one more time. Let's do another HCl at a pH. Let's do even lower. Let's say a pH of 0.5. That's going to give me a concentration of 0.3162 molar. Notice, this is a lower concentration than this. Lower pH, higher concentration. Now let's try something else. Let's say I have some sodium hydroxide, and it's got a concentration of 2.3 E negative 3. What's going to be the pH of that? Well, now this is a little bit different, because notice, this is not going to go through that same hydrolysis reaction. If I have NaOH in a solution, it's going to split up into Na plus and OH minus. We don't have any hydronium here. So we can't directly calculate the pH. So in this case, we need to calculate the pOH first. And so the pOH is going to be equal to the negative log of that 2.3 E negative 3. So let's find that first. And so our pH here is going to be 2.64. So our pOH is 2.64. So now I want to go from pOH to pH. How do I go from pOH to pH? Well, that's going to be using this equation. 14 equals pH plus pOH. Well, I've got the pOH here. I'm just going to put that 2.64 in for that. So that's going to be 14 equals my pH plus 2.64. So I can just subtract 2.64 from both sides. And so my pH will be 11.36. Now remember, anything above a pH of 7 is going to be more basic. So let's do a couple more of those. So I've got some potassium hydroxide with a 1.93 E negative 6 molar concentration. I want to know what's going to be the pH of that. So first I need to calculate the pOH. That's going to be 5.71. Then I'm going to take 14 plus pH plus that 5.71. So I can take that 14 minus 5.71, and that'll give me my pH. I get a pH of 8.29. Let's do this one in reverse. Let's say I've got some KOH at a pH of 13.62. Now I want to know, what's my concentration? How do I find that? Well, first I need to go from pH to pOH, okay? So that's going to be 14 minus 13.62, right? That'll give me a pOH of 0.38. So now I've got the pOH of 0.38, and I need to go from that to my concentration. In order to do that, I'm going to take 10 to the negative 0.38 power. That'll give me a concentration of 0.417. So, now we've looked at how to practice using all of those equations. Let's just cover, how do we know when we've got a base and when we've got an acid? Well, if we've got anything that has OH in it, right? We've got some, let's just say some whatever metal. Maybe it's a magnesium, maybe it's a sodium, but it's going to have OH in it. That's how we're going to know if this is a base. Then we're going to use all of the equations related to pOH to go from a concentration to the pOH. If we have something that has an H followed by some anion, like sulfate or chloride or nitrate, that is going to use pH. And if we want to go back and forth between these two, between pOH and pH, we're going to go 14 equals pH plus pOH. Okay? So we need to be cognizant of when we use which equation. We cannot go directly from an acid to a pOH, and we cannot go directly from a base to a pH. We have to go through this relationship right here.